This is 2020 MEXT College of Technology Mathematics paper. Let's begin. Section 1, Number 1. In this question, we need to solve a cubic equation. First of all, pay attention to the constant term, minus 2. Minus 2 is the product of either 1 times minus 2 or minus 1 times 2. So let's see what happens when we substitute x equals 1 into this equation. This is clearly not equal to 0. So what happens when we substitute x equals minus 1? In this case, the left-hand side and the right-hand side match. Therefore, we know that the second case is true, meaning that this cubic equation can be divided by x plus 1 times x minus 1. X plus 1 times x minus 1 is x squared minus x minus 2. So finally, let's divide this cubic equation by this quadratic equation. X times x squared is x cubed. X times minus x is minus x squared. X times minus 2 is minus 2x. 0 minus minus x is x squared. Minus 3x minus minus 2x is minus x. So the third factor is x plus 1, which means that this cubic equation can be divided by x plus 1 squared and x minus 2. Section 2, Number 2. We need to solve this equation for x. Recall that cosine of 2x is 2 times cosine x squared minus 1. Therefore, the left-hand side becomes 2 cosine x squared minus 1 plus 4 cosine x plus 3. Divide each term by 2. Let's factorize. So given this range of x, cosine x is equal to minus 1 when x is equal to pi. So this is the answer. Section 1, Number 3. We need to express this without the absolute value signs. So recall that given the absolute value of a, if a is greater than or equal to 0, then the absolute value of a is a. But if a is negative, then the absolute value of a is minus a. Therefore, we need to determine whether the inside of each absolute value symbol is positive or negative. So we know that pi is about 3.14. 20 divided by 7 is 2 point something. 3 sevens inside 23, and there are 2 sevens inside 20. Therefore, the first part becomes positive, whereas the second part becomes negative. So with the first part, we don't need to do anything. We can just remove the absolute value sign. But we need to put a minus before the second part. So the answer is 3 over 7. Section 1, Number 4. Recall that a to the power of b times a is a to the power of b plus 1. This means that 3 to the power of 2x plus 2 is 3 squared times 3 to the power of 2x. Also recall the following. A raised to the power of b raised to the power of c is a raised to the power of bc. Therefore, 3 raised to the power of 2x is 3 raised to the power of x squared. So the first term in this equation becomes 9 times 3 to the power of x squared. Now, let y be equal to 3 raised to the power of x, so that this equation becomes 9y squared minus 10y plus 1 equals 0. Now we can use the quadratic formula to solve this equation. So y is 1 or 1 over 9. Since y is originally 3 to the power of x, 3 to the power of x is 1 and 3 to the power of x is 1/9. In the former case, x must be 0. In the latter case, x must be minus 2. So these two are the final answers. Section 1, number 5. In this question, we need to solve this inequality for x. Recall the following rule. Therefore, log base 2 of x plus log base 2 of x minus 1 is log base 2 of x times x minus 1, which is log base 2 of x squared minus x. Next, log base a of b is greater than log base a of c implies that b is greater than c. Therefore, x squared minus x is greater than x plus 3. So this quadratic equation can be factorized as x plus 1 times x minus 3. So let's draw a quick sketch. X equals minus 1 and x equals 3. Because the left-hand side has to be greater than 0, we are concerned with these parts. So, x is less than minus 1 and x is greater than 3. However, log base 2 of x implies that x must be greater than 0. So the only answer is x is greater than 3. Section 1, number 6. So let's give names to these 3 points, A, B, C. When we know the coordinates of the 3 vertices of a triangle, we can calculate its area using the following formula. 1/2 times the magnitude of the cross product of vector AB and vector AC. So let us define vector AB and vector AC first. The x-coordinates of B minus the x-coordinates of A, the y-coordinate of B minus the y-coordinate of A, the z-coordinate of B minus the z-coordinate of A. Next, let's consider the cross product of these 2 vectors. So first, let's calculate the x component. When we calculate the x component, we ignore the x column, and then we do a times d minus b times c. Likewise, when we calculate the y component, we ignore the y column, and we do a times d minus b times c. And the same with the z component. We ignore the z column, and we do a times d minus b times c. So to calculate the x component, we do minus 1 times minus 2, which is 2, minus 0 times minus 2, which is 0. Let's move on to the y component. We ignore the y column and we do minus 2 times minus 2, which is 4. 0 times 0 is 0. And the z component, we ignore the z column and we do minus 2 times minus 2, which is 4. And minus 1 times 0 is 0. So we get 2, 4, 4. And next, let's find the magnitude of the cross product of vector AB and vector AC. To find the magnitude of a vector, we simply have to square each component and then add them up. So the area is 1/2 times 6, which is 3. And this is the final answer. Section 1, number 7. Looking at the form of this equation, we know that this represents a plane, because the general form of a plane in a three-dimensional space is ax plus by plus cz plus d equals 0. Now, if we have a line that is perpendicular to a plane and goes through the point x sub 0, y sub 0, and z sub 0, then we can say the following. So in this case, x sub 0, y sub 0, and z sub 0 are all 0. X over 1 equals y over minus 3 equals z over 2. Therefore, x equals y over minus 3, which means that minus 3x is y. Likewise, x equals z over 2, meaning 2x is z. Now let us substitute these values of y and z into the original equation. So x is minus 1/2. So let's substitute this value of x into this equation. So y is 3 over 2, and let's substitute this into this equation. So z is minus 1. So the plane alpha and the straight line L intersect at the point minus 1/2, 3 over 2, minus 1. Section 1, number 8. We need to find all the tangent lines that go through the point 0, 0, which means that all the tangent lines must be in the form y equals mx. And because all the tangent lines touch the graph of x sine x equals mx must hold. This means that m is sine x. Next, we need to differentiate the equation y equals x sine x. And to do so, we need to use the product rule, because x sine x is the product of x and sine x. So here's the product rule. So let's say u is x. That means u dash is 1, and v is sine x, and v dash is cosine x. Therefore, dy dx is u x times cosine x plus 1 times sine x. Now, dy dx represent the slope of the tangent lines, which means dy dx is equal to m, which also means that dy dx is equal to sine x. Therefore, x cosine x plus sine x is equal to sine x. Hence, x cosine x is 0. The left-hand side becomes 0 when either x is equal to 0 or when cosine x is equal to 0. And when does cosine becomes x? Cosine x first becomes 0 when x is equal to pi over 2. And from then on, we need to add pi to the previous value. So when x is 0, m is sine 0, which is 0. So that means one of the tangent lines is a horizontal line that goes through the origin, which is y equals 0. So this is one solution. Next, when x is pi over 2, etc., m becomes sine pi over 2, etc. Sine pi over 2 is 1, whereas sine 3 pi over 2 is minus 1, and so on. This means we also have x equals x and x equals minus x. And these are the final answers. Section 1, number 9. We have an infinite series n sub 1, which is defined by these two conditions. When n is 1, a sub 2, we know that a sub 1 is 2. So now we know a sub 2 is minus 1. So what happens when n is 2? We know from the previous part that a sub 2 is minus 1. So now we know that a sub 3 is 1/2. When n is 3, a sub 4 is minus 1/4. So the series so far looks like this. 2 minus 1, 1/2, and minus 1/4. As you can see, this is a geometric sequence with the common ratio of minus 1/2. So we basically have to calculate the sum of a geometric sequence. This is the formula for calculating the sum of a geometric sequence, where a is the first term of the sequence and r is the common ratio. So in this case, the first term is 2, and 1 over 1 minus, the common ratio is minus 1/2. So the answer is 4 over 3. Section 1, number 10. In this question, we need to calculate the limit of this expression as x approaches 0 from the left. There is one rule that will come in handy when solving this question, which is called L'Hopital's rule. The H in L'Hopital is silent because this is a French name, and this rule states the following. So basically, we can differentiate both the denominator and the numerator. So, in this case, f of x is 1 minus cosine 4x. So, f dash of x is 4 sine 4x, because the derivative of 4x is 4, and the derivative of cosine x is minus x. G of x, in this case, is x times the absolute value of x. Now, because we are approaching 0 from the left, x must be negative. So g of x is minus x squared. So g dash of x becomes minus 2x. Therefore, this is equal to this expression here. However, we still have x in the denominator. So let us apply L'Hopital's rule once again to eliminate x from the denominator. F of x is 4 sine 4x, which means f dash of x is 16 cosine 4x, and g of x is minus 2x. So g dash of x is minus 2. So now we have minus 8 cosine 4x. Since we no longer have x in the denominator, we can finally substitute x equals 0. Cosine 0 is 1. So, as x becomes closer and closer to 0 from the left, cosine 4x becomes closer and closer to 1. So the limit is -8. And this is the final answer. Section 1, number 11. Log base root e of root x plus 1 can be rewritten as follows. And remember that the exponent can be brought to the front. Therefore, this is equal to 1/2 times log base root e of x plus 1. Next, we're going to use the change of base rule. The new base c can be arbitrary, but we're going to choose e because it is a very convenient value. Now, root e is equal to e to the power of 1/2. And this exponent can once again be brought to the front. Log base a of a is 1. So this is equal to log base e of x plus 1. Now, recall that the derivative of log base e of f of x is f dash of x over f of x. The derivative of x plus 1 is 1, so f dash of x is 1 over x plus 1, and this is the final answer. Section 1, number 12. In this question, we need to evaluate this definite integral, and to do so, we're going to use a technique called integration by parts. Integration by parts can be used when we have a product of two functions. And normally, it doesn't matter which one is u and which one is dv, but in this case, we're going to let u be equal to sine x, dv be equal to e to the power of 2x dy. du dx is cosine x, which means that du is cosine x dx. Now, what is v? Since dv dx is e to the power of 2x, v is 1/2 times e to the power of 2x. Because to differentiate v with respect to x, you bring this 2 to the front, and 1/2 times 2 becomes 1. So now we have all the necessary parts to do integration by parts. So let's evaluate the first part. Sine pi is 0, sine minus pi is also 0, so this part will disappear. Next, we're going to integrate this part once again by using the same technique, namely integration by parts. So let u be equal to cosine x. So du is minus sine x dx. Let dv be equal to 1/2 e to the power of 2x dx. So v is 1/4 times e to the power of 2x. u cosine x, v 1/4 times e to the power of 2x minus v 1/4 times e to the power of 2x du minus sine x. So let's change this sign to plus dx. So let's distribute -1 to each term. Next, let's evaluate this part. Cosine pi is -1 minus cosine minus pi is also -1. So this part is equal to 1/4 times e to the power of 2 pi minus 1/4 times e to the power of -2 pi. Next, let us multiply both sides of this equation by 4. Notice that this part and this part are identical to each other. So let us move this term to the left-hand side, so we get 5 as the coefficient. And now divide both sides by 5. And this is the final answer. Section 2, number 1. In this question, we are given two matrices, I, which is the identity matrix, and A, and we are also told that A squared plus 2A is equal to minus 4 times I. So first of all, A squared means A times A. First row, first column. A times A is A squared. B times minus B is minus B squared. First row, second column. A times B is AB plus B times A is AB, which is 2AB. Second row, first column. Minus B times A minus AB. A times minus B minus AB, which is minus 2AB. And finally, second row, second column. Minus B times B is minus B squared. A times A is A squared. Next, let's calculate 2 times A. This is very simple. We just need to multiply each element in the matrix by 2. So 2A, 2B, minus 2B, and 2A. Minus 4I is minus 4 times the identity matrix, minus 4, 0, 0, minus 4. Next, A squared plus 2A. A squared minus B squared plus 2A, 2AB plus 2B, minus 2AB plus minus 2B, A squared minus B squared plus 2A. And we are told that this matrix is equal to this matrix. Therefore, A squared minus B squared plus 2A is equal to minus 4, and 2AB plus 2B is equal to 0. So now, we essentially have to solve these two equations simultaneously. Let's start with the second equation. So we know that A is minus 1, and let's substitute this value of A into the first equation. Now, in the question, we are told that B is greater than 0, so this means that B must be positive root 3. So these are the solutions to the first part of section 2. Section 2, number 2. In this question, we need to calculate the inverse of matrix A. So in general, the inverse of a 2 by 2 matrix can be found using this formula. Therefore, the inverse of A is A times A squared, minus B times minus B, which is plus B squared, times, swap these values, and change the signs of these two. And from the previous part, we know that A is minus 1 and B is root 3. And finally, let's multiply each element in this matrix by 1/4. And this is the final answer. Section 2, number 3. So the exponent 3n is telling us that something happens when the exponent is a multiple of 3. So let's see what happens when the exponent is 1, 2, 3, and so on. When the exponent is 1, we get the inverse of a, which is the answer to part 2. So let us calculate the inverse of a squared. First row, first column. So next, let's see what happens when the inverse of a is cubed. This is equal to the inverse of a squared times the inverse of a. So now we know that when the exponent becomes a multiple of 3, we get a matrix that looks very similar to the identity matrix. In fact, this is equal to 1 over 8 times I. Now, this is equal to the inverse of a cubed raised to the power of n, which is equal to 1/8 to the nth power times I to the nth power. I times I is I, so I to the nth power is I. Therefore, this is equal to 1/8 to the nth power times I. And this is the final answer. Section 3, number 1. So let C sub 1 be equal to C sub 2. Let's substitute this value of x into the first equation. So now we know 1, 3 are the coordinates of the point of intersection. Section 3, number 2. We need to find the equation of the common tangent line, L. So let's say L intersects C1 at the point x sub 1, x sub 1 squared plus 2x sub 1. And let's also say L intersects C sub 2 at the point x sub 2, x sub 2 squared minus 4x sub 2 plus 6. Next, let's differentiate each of these equations. So C sub 1 dx is 2x plus 2. C sub 2 dx is 2x minus 4. Now, let's call this point x and let's call the other point y. At x, C sub 1 dx has the value 2x sub 1 plus 2. And at y, C sub 2 dx has the value 2x sub 2 minus 4. Now, because L is the tangent of these two parabola at points x and y, C sub 1 dx at x must be equal to C sub 2 dx at y. So, 2x sub 1 plus 2 is equal to 2x sub 2 minus 4. So now we have arrived at one equation. X sub y is equal to x sub 2 minus 3. Next, let's consider the slope of a line between x and y. This should be equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here, let's substitute x sub 1 equals x sub 2 minus 3. So now we know that the slope between x and y is 1. And this slope is equal to c sub 1 dx at x, which is equal to c sub 2 dx at y. So recall that c sub 1 dx is 2x plus 2, and at x, c sub 1 dx is 2x sub 1 plus 2. So this is equal to 1. Therefore, x sub 1 is minus 1 half. So now, let's find the corresponding y value of point x by substituting this value of x sub 1 into this expression. So now we know that the y-coordinate of point x is minus 3 over 4. Therefore, the tangent line L goes through the point x and has the slope of 1. So let's find the y-intercept of L. So the y-intercept is minus 1/4. So the equation of L is y equals x minus 1/4. And this is the answer to the second question. Section 3, number 3. In this question, we need to find the area bounded by c sub 1, c sub 2, and L. So let us quickly visualize these two parabolas. C sub 1 can be factorized as x times x plus 2, which means that c sub 1 intersects the x-axis at 0 and minus 2. How about c sub 2? Let's calculate the determinant. B squared minus 4ac. Minus 4 squared minus 4 times 1 times 6. 16 minus 24. This is less than 0. So c sub 2 has no real solutions. Which means that the graph of c sub 2 will be entirely above the x-axis. And these two graphs intersect at 1, 3, and we know that line L intersects c sub 1 at minus 1/2, minus 3/4, somewhere here. So the area that we need to find is the area in red. So we need to find the x-coordinate of the point y, but we don't really care about its y-coordinate. Recall that x sub 1 is equal to x sub 2 minus 3, and x sub 1 is minus 1/2. So the x-coordinate of point y is 5 over 2. Now, one thing that we need to keep in mind is that between minus 1/2 and 0, c sub 1 is under the x-axis. So we need to take the absolute value of the area between x equals minus 1/2 and x equals 0. So basically we're adding 3 areas. This area under the x-axis, and then the area between c sub 1 and L here, and then the area between c sub 2 and L. So the first part is equal to 1 over 24. Let's calculate the second part. So the second part is equal to 13 over 12. Finally, let's calculate the third part. So the third part is equal to 27 over 24. So finally, let's add them up. So the area bounded by C sub 1, C sub 2, and L is 9 over 4. This is the final solution.